Hey, hi everyone. My name is Steph Chia. I am the Senior Research Manager at the UBC Department of Medicine, and I help manage the UBC Data Science and Health or DASH research cluster activities. So we're really pleased, DASH is really pleased to welcome you all to our first session of Vibe Coding 101 for Healthcare. What is vibe coding and why does it matter for health? But before we begin, I'd like to acknowledge that we're hosting today's session from UBC in Vancouver, which is on the traditional unceded territories of the Musqueam, Squamish, and Tsleil-Waututh First Nations. I also want to acknowledge that you may be joining from various locations and territories, and I also acknowledge the traditional caretakers of those lands. So for today's session, I'd like to introduce our main speaker for today. This is Dr. Omar Salim. He is a precision medicine physician, founder of Zinda Health, Zinda.health, a precision medicine platform for South Asian health. He is also co-founder of drvibe.ai, an education and development platform that teaches physicians and healthcare professionals vibe coding. So he is a Replit master level vibe coder with 150 plus apps built for real world clinical and personal use. He's passionate about helping physicians leverage vibe coding with AI tools to create practical software from scratch and directly influence the future of healthcare. So before I pass it to him, I'd like to share the Slido QR code, and we'll have the link to the Slido in the chat as well. So I'm asking you all to please use Slido for any questions you may have for Omar. We will be addressing them towards the end of the session. We'll save about 10 to 15 minutes for the end to go through the questions. And we're happy to have you join our session today and hope you get a lot out of our session. So I'll be passing it to Omar now.
Hey guys. So let me just open up the slide. Can you guys see my slide? Okay, good. So it's nice to see everybody virtually. My name is Omar, of course, as Steph mentioned. And so basically, we essentially at Dr. Vibe, we started Dr. Vibe as kind of a mission to really empower physicians to understand that AI can be a tool and a resource that can really empower physicians to become a 10x of themselves. So we have a series called the 10x Doctor. That's where that came from, and we wanted to focus on this series just to as an introduction to vibe coding, what that is, why it's important, and why it's so relevant for healthcare specifically. If you've seen a lot of the media takes, a lot of articles about how the AI is going to replace doctors and doctors aren't necessary. And this is our response to that. And essentially, our thesis is that using AI tools, doctors will become a version of a much more powerful version of themselves that we can really empower ourselves, but also provide the best care to our physicians. And this happens not just in terms of like in clinical practice. I know I was looking through who's attending, and most of the people here are in clinical practice in some capacity, but also in research. And that's where, and we'll talk about it later on, is how because of AI, research is going to exponentially compound, and how do we bring that to clinical practice, and how we use these tools for it. So without I'll get started, and usually I like to start with just asking, just to get an idea who's here. And it's, I know there's many people who only have used maybe ChatGPT, maybe have not used ChatGPT. If you're very rare if you haven't yet used ChatGPT, but just want to get an idea as to what level of the usage you have of AI tools right now. So if you could answer, like if you've used ChatGPT, if you use AI to make something like documents, discharge summaries, things like that, or you use a scribe, or you use some different tools within EMRs, or if you've built something yourself. So like if you've built an AI tool yourself, I know I saw that there's some people who are really passionate about vibe coding in the registration list. So if you build something, we'll be happy to hear about that in the chat as well. And of course, then if you're a seasoned veteran, just let me know, and it'd be good to see that. See, so looks like.
Maybe we can share the results. We'll launch the poll for your question and then we can share the results.
Sure.
And if,
Yep.
if those who joined late didn't get the Slido link, that we'll share it again in the chat.
Nice. Awesome. Yeah, so we'll move on to so essentially with these three sessions, and they're hour-long sessions, so usually there should be enough time to kind of get a good idea, good grasp rather on by putting how I wanted to break this down is kind of right now focus more on the building blocks and foundations of it. Like anything, when you learn a new skill, you have to kind of build a good layer of how you build a thought process around it. And that's what I want to have you kind of leave with today. And just like how is it that I think about AI as an assistant? How is it that I build a tool? Why am I building a certain tool? So th those are the things that we want to focus on. Next week or next, I think it's next time we'll focus more on kind of the research aspect. How is it that we bring in different resources, different research tools, and then finally later on we'll kind of bring this all together in a more clinical setting, and there we'll take it a little bit of the next level where maybe we'll talk about AI agents. We'll talk about different tools that we can use, and essentially we want to build on top of each session. So if you have any questions today, feel free to ask later on, and I'd be happy to answer them. And then just know that we'll keep compounding this so that by the end of these three sessions, you'll have a good idea as to how to build your tool and what problem it is you're solving. So so today we'll focus more on, like I mentioned, as to the foundational skills. So as far as the why, so again, going back to healthcare and data, we'll focus kind of how, this is the right time to learn skills like these. Then we'll talk about what are the three fundamental skills a vibe coder should know. So if you're dealing with any kind of AI tools, what are those skills and kind of how do you build that repertoire of skills? And then we'll try out a live build. We'll see how it goes. It's usually with anything like this, it's sometimes a little bit tricky, but we'll try and see. It'll be fun. And then we'll switch it over to you guys and kind of go from there. Um, so starting from the perspective of healthcare, so one of the things that's happening is that the data generation in healthcare is increasing at a considerable level. So essentially, every year we have a new tool and a new diagnostic tool or a new kind of test that's being formed, and then around that there's hundreds of studies, and then even within the studies that we have, there's much more granularity. Where like now I focus specifically on South Asian health primarily, and the reason I'm able to do that is because there's more and more granularity in how we're assessing patients and practicing medicine. So there's this data production will just keep compounding. So one of the things that physicians have to deal with is how do we kind of ingest all that information? And if you're a researcher, if you like run healthcare policy, like how do you get all that information? How do you understand it? So that's a big problem that's starting to happen, and it's almost like when the problem starts to happen, there's usually a solution that comes about, and this is that solution. So AI is able to take in all this information, synthesize it, and kind of bring it all together. So just to give you an idea, kind of how burdensome that data can be. So like 50%, I would say probably even more than 50% of time is spent just on documentation in the EMR. You have to go through a new paper that comes out almost every day, and then like if you had to see like how fast medical knowledge is doubling. Right now it's at 73 days, but recent studies have shown that it's actually getting faster than that, where it's about every 50 days or even 40 days. So that compounding knowledge, the one like it can become lead to things like burnout, but then it also can lead to a lot of gaps where sometimes our care that we provide patients may be falling behind as to what the latest research is showing. And then so now we have to kind of to shift over, and I think AI is one of those solutions for that. Is how do we bring in all that information in a way that we can understand? So now shifting gears towards like AI, like what is it, and as to how can it solve these issues? So there's three different ways that it can kind of help. So one is basically where it automates things, where it automates decision making, it automates different rules. Another way is basically where you have recognized these patterns that are coming from this research, but also patterns that may be coming from patients, and kind of build different tools from that. So this is prediction modeling, risk scores. Now we're seeing, different omics that are emerging where you have tests like TrueAge or the biologic score. So these tools are kind of being built in the machine learning. And then the last is generative AI, which is what we're going to focus more on today, which is, large language models that can ingest and understand a lot of information, and they can speak the language of patients, speak the language of physicians, and kind of bring it all together. And this is where our area of vibe coding lives, where we can really use generative AI tools as a way to make something that is either beneficial to us or beneficial to patients. So the what this has done is essentially kind of shifted from um, building tools from what programmers used to do to where anyone can do. And I think that that's the biggest message I kind of want to send out today is that it's just if you take home, it's like if someone's thinking, this is an app that, programmers needed to make this. I would argue that you can make this and anybody can make it. They just have to kind of speak the language or speak the language and just have kind of say in English, this is what I want to be made. So that's the if there's one thing, just you take home, just try it out and we'll go over it later. But it'll really change the perspective on like how we approach kind of tools. So when you see a program, you're like, okay, maybe I can make this customized for myself, and that's basically what vibe coding is. Now, the I like to bring in this example primarily because I think we're at an inflection point in healthcare where right now the tools that we see, and I think this is more important, especially for those who are maybe in med school, who are in training, is that right now the tools that we see out and about that are AI powered. So think of like scribes or think of maybe like the EMRs that have AI tools. I consider them faster horses. And I think the reason I say that is because what they do is essentially they speed up or they improve processing of something that's already in our system that exists from an older system. Essentially, think of like labs, like you're still doing labs every 3 months, and it helps process those labs. Um, what we're going to see in the next 10 to 15 years is a shift towards where AI itself will become that software. And much of that software will be powered by vibe coding, where we already have many, and this is outside of healthcare, where we already have many tools that are being built on demand, is what we call a concept we call just-in-time software. And these are being built on demand as the need arises, and they disappear after that. So it's just-in-time software is going to become more and more the standard. And this will become more and more granular, where you'll have just-in-time software that forms for a problem that comes about that once that problem is solved, that software is now discarded and something new will come about. So a good example of like is if a patient comes in with say diabetes and they have a diabetic foot, you can create a just-in-time software that does like an image analysis of their foot, gives them a whole protocol. Once that foot is improved, that software is now discarded and something, and then we basically have the data start just kept. And so that's kind of the transition that we're having. And I think vibe coding will become a tool, just as maybe using an EMR or just as like writing a prescription. That'll also become a tool that'll be inherently part of physician practices. So that's one of the reasons that we find this very important as a skill to learn and to understand. So now going back to what we had talking about spoken initially was the skills. So and we'll talk about the three different skills of vibe coding, but first thing I wanted to mention is that it's the the person who's vibe coding, and I think this is a big shift that's happened over, I'd say, the past 2 years, is that the value of the person doing the vibe coding is as important, or what they're providing is as important as what's being built itself. And what I mean by that is, if you think about, if you go back to how software was built, maybe like I started in software maybe 10 years ago, and the way it would be done is that you would basically create like a what we call a PDR, or a term sheet of like, this is what I want and to be included in the software, and this is something that I want to be built. And then the engineer would go, usually be somebody who has some information about like what's done in a clinical setting, and then they would go make it out, and then they would give it to you, and you're like, okay, this is not kind of what I was looking for, but this works and this gets the job done. And this is one of the reasons why, if you see EMRs, why there's such a hard problem with that, is that that's one of the reasons why that is. So what is changing is that the what vibe coding allows is you as a domain expert. So if you're a physician, if you're a researcher, you're a policymaker, if you are writing a paper, so you yourself decide what goes into the software, and you yourself decide what are the priorities. So, and the reason this is important is because as physicians, we have a good understanding that of what subtleties matter and what nuances matter, which anyone who is not in that domain doesn't understand. And this is true with any domain. So, like if someone is a lawyer, they would understand what is it that in a legal program is matters, and if they're in space and they're making something for rocket, they would understand that. So the same thing in medicine. Those nuances is what you can add on into the app, which you previously could not. So a good example here is like TSH. Right now in EMRs, all it is basically comes up yellow, red, or if it's normal. But they don't include, patient context, where if they've had any weight changes, how they respond to medications. If there's subclinical patterns where they're like, well, maybe my heart is racing, or things like that, that only a physician would really pick up. And so those are things that now you can build an app around it, and you can include it. Same thing with research. So research is essentially where you have certain markers that normally no one would really consider these. Like only in an abstract would you see them. As a researcher, you're like, well, maybe there's certain patient pools that no one has really looked into. Let me go and find those. So now you can actually go into PubMed, have an AI run through case reports, case series that previously had been unseen, and now find patterns that previously were never realized because they were never analyzed. And using the power of LLMs, these can be built. So that's one of the reasons I feel like more and more physicians should go into vibe coding, is just because the expertise they provide, no one really else can replace that. Now, I wanted to focus on what vibe coding is not, and I think this is important, especially because in healthcare we're dealing with a lot of sensitive information, and the implications of this. These are very important. And the first thing is that this is not a replacement for any kind of engineering or like sophisticated what we call a prod level, so production kind of deployment. And the reason I say that is because there's a lot of security, there's a lot of auditing, there's a lot of nuances that go into that you really have to protect patient data. You have to protect the implications of certain diagnoses that the AI can come up with, and especially when it's patient facing, that's even more risky. So that's some things we try to avoid, unless you have a whole team that has, an engineer who can do red teaming, which is basically creating guardrails, making sure that there's a human in the loop, and all those certain validations are done. The other thing is that and this is very personal to me, is that the idea of garbage in, garbage out. So you always have to make sure that you're like in anything, like if you're doing a research analysis or meta-analysis or systematic review, you have to make sure that the data that's going in, or whatever is going in, has to be high quality so that you get good results. So what I mean by that is, you can't expect it just like a good example is you can have just say tell ChatGPT, just look at all the studies on PubMed and find me, what medication works and what doesn't. It really doesn't know what with that, and it would have no idea as to where to start. So the idea is just to think of it, and we'll talk about systems building, but just building systems around it. So like if there's a codified system of like this is how we do things, this is what we expect to see as an answer, then the quality will match that. So that's extremely important when it comes to vibe coding. And then lastly, hallucinations, which is extremely important. Actually, both hallucinations and omissions as well, which is not what doesn't get as much attention. And hallucinations, we all know, is basically when AI tends to make things up. And the reason is that LLMs by nature are what we call probabilistic models. So what that means is they basically are guessing or based on statistics what the next word will be. Not even the next word, but the next letter even. So they are literally just guessing the next letter. And this is why you need so much compute and things like that with it. But one of the drawbacks of that is because it's guessing, it can think that it's guessing the right way, even though it may be based on the wrong statistics. The other, and I think as dangerous issue, which a recent study at Stanford kind of showed this, was that it tends to omit a lot of things that especially in medicine that may be important. So in the Stanford study, there's a lot of patients who had pulmonary embolisms, they had an MI happening. It failed to mention that at all. So that's something that we also have to kind of, if we're building tools that are more clinical use, that's some things that we have to consider and kind of have a way to assess. So those outputs, when you make tools, you always have to consider, is the result or the quality of the output optimal? And is it something that I can, rely on? And does it have enough guardrails? Does it have enough validation that kind of allows someone to rely on these outputs? So that's why I would say that, especially at this stage where we're at today, vibe coding is amazing for personal tools, for automations you can build, and then also research, and we'll talk about kind of research next time. But those use cases are amazing. The harder and more difficult to apply use cases are more getting it towards production and kind of using it as like a day-to-day app, which requires months and months of development, months and months of validation and red teaming and setting up guardrails. So just to kind of step back and go back to the history of vibe coding. So, and I am not a big fan of the word vibe coding. So the reason vibe coding is called vibe coding is essentially the last year in February, Andre Karpathy, who's considered, I mean, one of the foremost minds on AI. He's the one who built Tesla's AI, and now he essentially just tries different use cases of LLMs. And he coined the term vibe coding through a tweet where he said, "There's a new kind of coding I call vibe coding, which is fully giving into vibes." And one of the reasons I have a problem with that terminology is because vibe coding is it can be a very serious way to build any tool. It can be you can be extremely productive with it, and you can make production level tools to the extent where now even Claude, most of the new tools that are built by Claude are vibe coded by the Claude team. So even though it's based on vibes, it is a very serious area that I think it deserves that kind of respect. So yeah, and then the other differentiation I wanted to make was between vibe coding and no code, and that's also extremely important. So vibe coding is where you can build any kind of tool from the ground up using communication between you and the LLM. No code is something quite different. No code sometimes gets bunched into vibe code, and no code is essentially like a canvas that's created for somebody with limited uses. So essentially, it's connecting one node to another node, but those nodes are already created and already set up. So you can't really be flexible with those. So someone can still make an app with no code, but they can't really customize no code. versus vibe code can be customized to the to an exponential level, just using English and just talking to the platform in English. So and that's the biggest difference. And like I said, it's the specification. It's like the your vision that you personally have that can really come to life with vibe coding. And that's the biggest thing. So, and the last thing before we move on, the tool. So there's a lot of focus on tools. Like there's very ardent fans of Claude versus ChatGPT or Codex. Within the IDE platforms, it's either Replit or Lovable. One thing I want to say is that it really doesn't matter. It matters to a certain extent once you get to a point. But to get started with vibe coding, it's all about just building the skills. And then once you have those skills, you can use like anything. If you're using a pen or a pencil or a marker to make something, if it's all about just having the skill to do it, and the medium or the paint essentially becomes irrelevant. And so that's after that. And we'll talk a little bit more about the tools later on, and then also the next sessions. But yeah, so to me, like it's all about just building the skills. So so just to understand kind of where vibe coding is on a spectrum of like usage of AI, and we had asked this earlier in the beginning, and the reason I had asked this was just to understand where everyone is in their AI journey. So um, with vibe coding, usually we would put like I would add that as more of a building skill. So if you think of ChatGPT and just the text platform, if you're just using it just to interact with the question and answer, kind of like a Google, then it would be level one. And then of course level two is where you can really do prompt engineering, adjust the settings to where it's customized answers answering to you, and then also like making things like discharge summaries and tools like that. And then vibe coding is what we call where you're building tools, where you're using the LLM's ability to code and to build something new, and then kind of using that inside of it. And then lastly, it will be AI native systems, which maybe we may get to at the end of session three. But that is where the LLMs are doing a lot of the work for you, and they're being proactive, and that's the ultimate level that we can get to. So. Now, the going back to English, so with vibe coding, all you need to know is English. All you only need to, and I don't mean to say just English, but you can speak any language to the LLM, but all you need to know is just talk in your language, what you speak, and it'll understand. You don't need to know a single line of code. Later, if you get to advanced points, then it might be helpful to understand, how systems are structured, how different builds are, but that's something that is very iterative. Now, as far as skills, so these are the three skills I feel is all you need to know for my coding, but also three skills that I highly recommend to really nail down when thinking of what to build. So the first thing is thinking in systems. So basically, when you or by putting something, you have to think, am I, what problem am I solving for? And that's where first principles really come in. Is like, is there a way to solve this problem in a better way? So think of EMRs today. So EMRs today they solve multiple problems, but they solve those multiple problems in very complex ways. So, and this is one of the reasons burnout is such an issue. Like if you wanted to order a medication tomorrow, it takes 13 or 17 clicks just to get to that. Or if you wanted to see a patient's history, it takes another 12 or 13 clicks to see that, and then going through different places where it may or may not exist. So it's important to think of what problem are you solving and how can I solve it the most effective way or from a first principles way. And then breaking them down into, okay, these are the parts that I need, this is what I don't need, and then kind of coming to a resulting structure. That's extremely important. And I feel like physicians are uniquely positioned to understand this because they also think in the same way. They think in differentials. They think we or not they but we think in probabilities. And our goal is always to understand, if something is happening, it goes back to like Occam's razor. What is what is the simplest solution, but also what is the most likely solution based on the evidence that we have. So that's thinking in systems is extremely important because you want to build out the system in a way that is durable long term. And so it goes back to it goes to the next idea, next concept, which is iterative thinking. And iterative thinking is essentially where if you have one idea that you want to build, when when you speak to the LLM, you always have to think of, is there something else that I can add to this? Is there something else that can be improved? How can we kind of evaluate it? So iterative thought is something that will become a bigger skill in the coming years, especially as we move from a knowledge type of skill in medicine towards more where we refine and optimize our thought process. So where right now, where as physicians, we're more, do we know what the issue is? How can we diagnose it? How do we treat it? Iterative skill will be more is if someone is having certain things, what are the tests that are available? What have they shown? Can we use an LLM to improve this or improve this process or understand the skill? And then later on, in build systems that are more dynamic to kind of come up with solutions for it as those solutions also get so get exponentially multiply. So and that goes back to the idea of creating treatment plans. So as when we are seeing patients, we when we give the first medication, it never always works. So we have to keep refining. We're like, okay, well, let's visit another antibiotic or let's visit another glucose control medication and kind of go from there. So that's extremely important in building AI systems because everything will keep changing. As LLMs get better, that will change. As knowledge changes, that will also change and evolve. So that's important. And then lastly is clear communication. So the AI builds and AI listens to what you say and describe in a very specific manner. So and we'll see an example of this later on, is if you have even one letter in the wrong place, it can think of something in a completely different way. So that's extremely important to understand how you're communicating with LLM to get the right response from them. And any kind of ambiguity kind of it leads to a lot of different avenues, which can sometimes lead to a lot of what we call drift. And that drift can be problematic later on down the road because then you'll always keep coming back to, why is this problem happening? So the same thing is like if one is communicating with physicians about a case, then to make sure that the sign out has the right properties. Same with communication with patients to make sure that patients understand what's going on. Same thing with an LLM. It's just have to be just on point as to what it is that we want from the LLM. So and that leads into kind of just writing out kind of a prompt or a tool, just building that out. So um, and this is something that for me personally was very powerful was I used what I wrote or the skills I built writing papers, but then also eventually writing patient notes into understanding, how is it that we write out prompts and build out tools. So the so as physicians, we talk about, cases. This is the patient's age. This is what's going on. This is their past medical history, and this is what we want to do. And same thing with the research. This is the medication that we're testing. This is the outcome that we're testing, and this is the population we're testing it in, and this is the method we're using. So when we build with vibe coding, those are the same principles we want to apply. So when we talk about, if we want to build a tool, we have to be very, very specific about, these are the patient characteristics we're looking for. Instead of saying, just labs, we have to specify, TSH or the troponin and specifically those. And if we're building out visually tools, then we have to explain, we want this in a table versus we want this in a graph, and if a graph, what type of graph? All those things are very important. And then the last thing is going back and talking to the AI as a partner in building this. So I think that brings back the iterative skill where if something comes out differently, go back and talk to the LLM to kind of improve it and adjust it. And LLMs they always listen and they'll always say, we'll do it, but sometimes it'll be very confidently in the wrong direction. So just directing them in the right way is very important. Now, the so yep, so that's the most important kind of the thing is just to kind of build it out and kind of go from there. Now, I wanted to just do a demonstration and build this out. I think we have enough time. Hopefully, this will be this will build quickly. But if not, I do have a prototype that's ready. So just before so basically, I wanted to build something that kind of brought in different tools, and we'll talk about the iterative skills while we're building this. But essentially, for this, we'll focus more on just getting like abstracts, and then using those, and then using an LLM to filter out and ingest that abstract, and then coming up with a table that kind of shows us. And then we'll add on more tools later on as we go. So let's do that. And so, yep, so this is the prompt that we're going to use. I have the prompt ready. So I'm going to go in, I have to change my screen. Okay. So the tool we're going to use is called Replit. Replit is what we call a IDE workspace. And the reason it's called an IDE workspace is essentially an IDE is in programming is basically some place where everyone codes and makes apps. Replit is my recommendation, or Lovable even if no, I'm not very agnostic to all of them, but either Replit or Lovable. And the reason I recommend starting with those compared to like Claude or ChatGPT is they take care of a lot of the like work for you that may be needed when you start like coding. And then once you've gotten a hold of it, then Claude Code or ChatGPT Codex, those are amazing tools as well, that are very useful. So basically, we want to build this app, and so just to deconstruct the prompt. So we wanted to build. I been again using language goes a long way. So if we don't use elegant here, it'll make any kind of web app. It won't. Sometimes it doesn't look nice, and we want it to look nice, at least a little bit nice or presentable. And then the second thing will be, what does that app have to do? So basically, where a researcher can paste abstracts and define inclusion and exclusion criteria. And then the next thing is what else? So now we go into the more granular details of like, what is it that it should achieve while we're inside the app? So the app should screen each abstract against the criteria using AI, classify each as either included, excluded, or maybe, and then provide a one sentence reasoning as to why it did that. And then it can also extract sample size and primary outcomes as well. And then I'm gonna yeah, and then you can and then you should be able to add more abstracts in there if needed. And I like to add this to everything that I build. And the reason I do that is because, and I even now, like to this day, I do this. And the reason is that this helps guide you to understand what it is. It's kind of like a communication to the LLM as to what it was thinking, as to why it made something. So the instructions and guidance on how to use it are more of a reflection of how it thought about the prompt and what it wanted you to build. So that's why I do it. So then we'll just get started. Um, so while it's building that, so essentially what it's going to do now is it'll take the prompt, it'll try to understand it, and then it'll start up the different kind of the different tooling around it. So essentially, so it gives you a recommend or summary of like what it thinks that we want to be made. The nice thing about Replit is that it has built-in AI integration. So normally, if you want to build anything with LLMs, you have to connect an API key to have any LLM run on the platform itself. So say like you use the OpenAI in this app for the LLM. So you would have to get an API key where OpenAI would give you the tokens to use LLM within the app. And while this is running, I wanted to just go through like a few things. So when we vibe code apps, there's four big use cases that we are can do. So the first one is automations. So automations is essentially very simple things. So automation is like every morning, just when I wake up every morning at 8 a.m., send me an email on like this is my calendar events for today, and just give me a briefing on those events for today. That's a simple automation. You could take those automation even further, where it's like every morning send me, pull from PubMed, summarize all the papers that have come out over the last 24 hours, or more realistically over the past week, and then just summarize and give me a briefing on all those five papers based on my field. So if someone's a cardiologist, then they'll get all those papers, and they'll get a list of those, and if they're relevant to that, and then so those are automations. The next level is what we call more deterministic. So basically rules based. So if you can build an app that has different tools, and this tooling is basically based on certain rules. Like if it meets certain criteria, then it's in the red, in the green, or in the yellow, kind of how we see it with labs. And I can give you an example of that. So if you guys can see my screen, so this is kind of like a rules-based app where all it is you upload a CSV of a CGM, and what you would see is basically, is this falling in the right level? Is this falling in the red level? Is this a yellow level? And then we can and this has no use of AI. All it is, it was built by AI, but it doesn't use AI at all. So that's what we call a rules-based app. Now, we can take this another step further, and which what we want to do here today, which I was hoping to be done by now, but it basically where you build in LLMs into your app itself. And what those LLMs do is they can do different roles. So in our case, what we wanted to do is synthesize. Basically take a paper. Actually, we're not even taking a paper. We're taking text that we're going to paste, and then it's going to summarize it and synthesize it and organize it. So that's a simple use case of an LLM where it's not pulling from anywhere, and then it's just going to synthesize it. And the fourth level is agentic. So agentic LLMs are basically where they themselves will, and these are what if you've heard about OpenClaw or Hermes agents. So those are basically AI agents that kind of do everything on their own, and they kind of think about it. So there's our app. So it did get built out quite significantly. Um, so here's a protocol guide. So it made a whole guide as to how to use it, so it has the inclusion criteria here, has the exclusion criteria, and then here it has the abstracts. So let me get. Let's see. If I can. Okay. So yeah. So let's do this. It's hoping to be done by now, but it's not. So let me find, all right. So yeah, so let's add some inclusion criteria here. So what we'll do is we'll check, since they're in the vogue right now, GLP-1s, we'll check for some studies on GLP-1s. So basically what we want to do is see what recent studies on GLP-1s had included cardiovascular outcomes, and also had an RCT design. So they weren't just any case reports or case series. So we'll get an inclusion criteria. So basically we want an RCT design, or actually I have it set up so just so we're faster. I have the inclusion criteria. So basically we want anyone who's an adult, and a non-diabetic patient population. So basically, if and going the other way, if they have any kind of diabetes, we want to exclude that. And then we will paste. So we want this criteria, and then we'll get an abstract, and then we will paste the abstract in here. And then once the abstract is in there, so it's going to screen this. And what it's doing is when we hit the screen button, it's sending all of this to GPT 5.4, which is integrated, and then it will assess it, analyze it, and then give us a response. And sometimes the response isn't great, so we might have to edit it, we might have to optimize it and improve the prompt. So here's the result. So poses. So the basically it showed, yep, so this is what this is, it's a maybe as being included. This is the reasoning that what it showed. This was the sample size, then the outcomes are included. And so that's all in there. So now the thing is, this is very tedious, like having to put the abstract each time. It's like why should we be doing that? So PubMed actually has an API where you can connect into Replit. So I can tell Replit is like, this is quite tedious. Can we actually just use the pub? Can we let's make it even simpler than that. Can we actually just connect to PubMed and bring in the data from the studies? So um, PubMed has a free API, so does medRxiv. So Replit already knows this. So that's one of the beautiful things about Replit and Claude, and they already know that they not that they know, but they can actually search the internet. So if something has an open API, so you think of like weather. So if you want to do any studies based on like what the climate was in certain places, or if it's location, so you can actually get there's a free API to get a lot of satellite images and things like that for different regions for weather, but for other reasons as well. And then same thing with with PubMed and also medRxiv, so preprint servers as well. So they can get this. So now it's going to automatically add the API. I don't have to add any API, and it's going to think through that, add it in, and then and it's creating the route to it. It's setting up the backend, setting up a whole database for it, and then once it does that, then we'll be able then yeah, then we should be good. And then since we only have 12 minutes left, any question and answers while this is doing that, and then we can kind of do that kind of at the same time.
Do you want us to go to the Q&A screen?
Yeah, I think we could start that, and then it'll
Sure.
take maybe another 2-3 minutes, and then and we'll go over this in depth next session. Basically, the goal next session will be, and I can show you examples of kind of what our goal will be with basically making and essentially making kind of like this. I don't know if you guys can see this. Yep, you can see it. So basically bringing in different research papers. This is I use this just for my own personal use. This has no like, and this is basically to understand, different AI models that are coming into clinical practice and get an idea as to where we're at. And it essentially goes to a paper and brings in, so say like today, so this was a paper that came out today on like fMRIs, and then it breaks it down through PubMed as to like what the clinical implications of it are, what are the innovations of that paper. So that's something that we'll focus on next time to build out and really get you guys going. So it's still working on it, but yeah, we could go to the Q&A
You
and
can
kind of see.
ask, I can read the questions out to you.
Sure.
Okay. One question is, if we want to build a website where AI is embedded for metrics and maybe to flag certain things to the clinician, can we do that with vibe coding?
Yes, definitely. So that's what this does actually. So sends me, so this gets a, so just to give you an idea of how this works, and this will answer the question, is that what it does is it gets papers. So every day, it goes every morning at 3 a.m., it runs through, gets all the papers that have come out that are relevant to AI and healthcare. It breaks these down into like what the paper is about, clinical implications, and the innovation. And then here, it also, the associated model that's come out, the AI model with this paper, it gives it a, it does an assessment on it. And what that means is essentially it'll, once it does the assessment, it'll give me a score and it'll send me, and it'll notify me what the score of that is, and with the model card and everything. So definitely that's something that we can, that vibe coding can do, and it's actually good use of it.
Okay, I have another question is why again would Replit be preferable as a starting point versus Claude?
Yep. So depends on the goal. So if the goal is automating tasks and things like that, then Claude is fine. It's actually a good where you can go into Claude and use Claude automations and set up those like I had mentioned with the email or the calendar. If wanting to build out an app, Replit, so if we were to do the same app that we just built out in Claude Code, we would have to go to OpenAI, get a key, and then install that key. And then same thing with PubMed, we would have to go grab a PubMed key, which is also not available. So we would have to sign up. So you have to put an email and everything, and then you would get that and put that in. And the other thing is security. So like with apps, you have to make sure that when you get those keys, if the file is exposed to the internet, then anybody can actually get that key, and then now I can copy that key and I can start using it on someone else's dime. So from a safety perspective, that's also important. The last thing is the UI and the UX. So if someone is making like an app, the design, like an app that they want nicely designed like this, Replit has a built-in design system versus Claude, you have to use either Figma or Paper and get that design optimized. So Claude or Codex, both of them are very much of a headache when it comes to UI. And which is user interface. So that those are and the reason for that, just to go a little bit deeper into that, is that Claude and Codex are not native multimodal models. What that means is they can't see. Gemini, which is Google's model, it can actually see and it can visualize. So that's why most platforms use Gemini as their UI, and then they use Claude and Codex as the backend, which they're amazing at coding. So that, and what Replit does is that it brings all of those together. So it uses a design system built with Gemini, and then it's coding with Claude and Codex underneath. So all of that is done together.
There's like another question with 4 upvotes, so maybe we can do that one and then we can go back to your finish up
Sure.
the
Yeah.
webinar. But what this question is about are free versions versus and paid versions noticeably different in how effective they are.
Yes. So it depends on what we're discussing. So if it's ChatGPT, there's a massive difference because ChatGPT's free version only has the 5.4 minis, what they run primarily, and they don't use a thinking model all the time. So and that's why a lot of the studies, if you look at the studies that come in healthcare with that have a lot of hallucination, things like that, those are actually using a lot of the free ChatGPT versions instead of the thinking models, which have shown to be higher. In terms of performance. So definitely for that. For Replit, unfortunately, Replit is only paid right now. So so with Dr. Vibe, if someone signs into Dr. Vibe, they actually get $10 in Replit credits, and so that's something. But with Claude as well, Claude will only, I think Claude Code and Claude Cowork are now only paid. So there is a big difference in terms of like if you wanted to build apps, more than likely it would have to be the paid tier of most of them, unless one was to build something like Claude without the Claude Code components, which can be a little bit less robust.
Oh, one more quick question if you can.
Sure.
Uh, on Replit, how do you get the source code out so we can host elsewhere?
Yes. So on Replit, it's over here. So on the right here, you see this right panel. So in so they made it so over the last I've been using Replit AI agent since the day it came out. I was one of the first users of it. Um so before it would just be right here. Now it's inside this file tree here, and then you can go in and hit these three dots and download it as a zip. So once you download that, you can get the whole and that's actually there's a lot of times where I do this where create a nice UI and interface and then take that file, put it into Claude Code and have Claude Code do the rest. Because it's a lot more effective at coding that. And honestly, it's a bit more cost effective because Replit iterating it, like if you see here, that this part already cost $1.63. So it's a good option to where you can create a basic framework where everything looks nice with Replit, and then it cannot be optimized with Cloud Code. And then so while we're doing that, let me just so essentially so for PubMed, we will look for yeah. So essentially, I wanted to show the PubMed API. So essentially, we'll just do GLP-1 studies in past 4 years, and then I clearly can't type. And then it also so yeah so it went in and got everything from PubMed directly. So all you have to do now is just import these into as manual, or you can, and this was super fast too. So you don't have to add in any abstracts or anything like that, and you can import them manually, or you can have the AI screen those 10 abstracts and then add them into the platform. So that was done directly through the API, and now the LLM will take care of all of that. Um, so this can be taken to another level with agents, where the agents now you can schedule the agents every night to go through, come up with papers, and in the morning you would have all the list of papers, um, and yeah, so it's just there's a lot of avenues. So and this is where the domain expertise is big, right? So like if someone knows GLP-1 medications or if they're in the research space, they have a better concept than even I would as to what direction they want to go. And that's the beauty of this is if you can do it yourself, you're going to take it 10x, 100x better than someone who has no idea as to that space. Cool. Any other questions at all while we wait? This just LLMs are slow though. That's the only
Want to
thing.
ask,
And
see a few more questions? Okay.
yeah.
Can we not do this using deep search on ChatGPT and adding the website links to the search category?
Yes and no. So yes, that's possible. What's not that's definitely so deep search has a big role, has a big place in this. So especially when it comes to research papers, like getting the right research paper, the one thing that it won't be able to do is say like we want to so what we can do with this is have this run on a more frequent level, export this data if we want to, or customize how this data looks as we want to. So the deep search has a role in finding those papers, and then giving us like a summary of it and writing those out. That's a very useful form of it. And actually, you can connect the deep search, the GPT deep search, or even like Claude has a Claude Scientific. So those can be connected into this to give this information. But the value of this is more that it can be customized based on how you use the LLM essentially. So yeah, so these are all the different studies, and none of them met the criteria, so they were all excluded. I guess they were all in diabetics. Um, so which is very interesting to me. So, and this goes back to the iterative skill, right? So that's why like that was one of our main skills with vibe coding. This is never going to be on the first what we call it one shot. So in vibe coding, it's called one shotting, and so like it's not you. It's very rare that you can one shot the right app out of the box. And there are that we are getting closer to that where it's getting to a point where that can happen. But it's one of those things that needs like iteration, and just improvement. So now you have to go through and see, okay, why was this excluded? And the beauty of this is that now I can go in here and plan, and this you could do with any of them, like Claude with all of them, and just ask, the I saw multiple excluded studies. Why is that? And then it will actually go through these results that came in and try to understand why that happened and what was the how was the prompt and why that occurred. So so yeah, so so this kind of gave me an example of this. Um, and then kind of how to improve. And then you just keep asking it how to improve and it'll just keep improving further and further. So yeah, this is just so we'll go deeper into the research aspect next session. I think that that'll be something that we'll talk more about as to how to really display research in different ways, like charts, graphs, and then also creating notifications if you want emails to be sent to you directly about certain research that comes out. That can also be done, and then different ways that it can be iterated and expanded on. But this was just something that literally just within 10 minutes we wanted to kind of show.
Thank you, Omar. Yeah, we've reached the end of our session time, unfortunately. We probably could have gone longer with so many neat things to show and how you've just built something so quickly within the 1 hour session. It was like pretty neat to see. I wanted to thank everyone for attending our session today. Omar, did you have anything last things you want to share before
Yeah,
we let people go?
definitely.
Just
So
let
I
everyone just
so
let everyone know that this is a recorded session and we will share the recordings with the meeting registrants. Um,
So, so yeah, so for next time, so next time we'll focus more on research, clinical research. But if you have any ideas, we'd be happy to kind of go deeper into that. So I'm always like very curious to hear like what someone's interested in as far as like research tasks. So let us know, and we can focus on that, and we can build one of those out together and it'll be a lot of fun. And the one thing I'd recommend is creating like a free Replit account. Like I said, on Dr. Vibe, we have the $10 credit, so you can use that. But just know that it can get to just be very, very careful with the pricing because it can get kind of add up sometimes. And then Claude is of course free, so you can create a Claude Code account or a Claude account, and then you can use that as well. And then we'll build on this next time.
Thank you so much, Omar. So just a reminder that session 2, Building Research Tools with Vibe Coding, is on April 29th at 12 p.m. again in 2 weeks. So looking forward to seeing everyone again there. We might send out an email to get some of the feedback you want for that before that session 2, so you know what kind of app people might be interested in building. So look out for that. And I just want to thank everyone again for attending our first Vibe Coding 101 session. Thank you all.